Hey guys, today we're going to talk about ellipses and hyperbolas. So we're going to start with the ellipse. I've got some information here for you in this table. You have the basic equations for what an ellipse looks like, and kind of pictures of what they look like. So when you're looking at an ellipse, it's kind of like an oval shape, but it's got a little bit more specifics than just an oval. So if it is parallel to the x-axis, then when we're looking at it, that would be this one, parallel to the x-axis. What that means is that your bigger number, your bigger number is under the x. If it's parallel to the y-axis, that's this one right here. What that means is the bigger number is under the y. So that's kind of how you can tell which way it's going to go, which number or which letter has the bigger number underneath it. That's kind of the only difference there with the ellipse. And then that also kind of tells you where the vertices and the foci and everything are going to be. They'll be either on the x-axis if it's parallel to the x-axis or on the y-axis if it's parallel to the y-axis. So just like circles, our center is that h and k, x minus h, y minus k. And then your vertices come from that a, that denominator that we were just looking at. So you just add a to the x or subtract a from the x if it's parallel to the x-axis, or you add or subtract it from the y if it's parallel to the y-axis. Then the foci is where it gets a little bit, I don't want to say trickier, but a little bit more interesting. So that's what this equation is right here. C squared equals a squared minus b squared. So just to kind of break it down a little bit, this C right here is going to help you get your foci. So that's this right here. The A we kind of already talked about, but the A is the part that goes with the vertices. And then there's also something called the co-vertices, and that's what the B is. And that's the part that's under the other letter, and so it goes with the other letter. So if it's parallel to the x-axis, the vertices are with the x-axis, and the co-vertices would be here and here, and they would go kind of parallel with the y-axis on what we call the minor axis, as opposed to the major axis that goes with what it's parallel to. So this is kind of a lot of information here. I feel like it's a lot easier to look at this when you're looking at an example. So let's go ahead and start looking at example one right here. Example one says graph the ellipse and identify the key features. So the first thing you'll notice is that our bigger number is under the x. So that means that it is going to be parallel to the x-axis. So it's going to open like this. Okay, and you will also notice we're dealing with a whole bunch of squares again. And so we are kind of looking at a squared there. So that a squared is 81. So we will have to kind of talk about, square rooting that and everything. Let's start by looking at the center, though. So the center comes from the h and the k with the x and the y. So x minus 2 means that we're going to have 2 for the x part. Y plus 4 means we're going to have negative 4 for the y part. So I'm going to go ahead and come over here, and I'm going to put my center at 2, negative 4. Then, to find my vertices, I'm going to use that 81. The square root of 81 is 9, so that's what I'm going to use for my vertices. And we already talked about how it's parallel to the x-axis, so that 9 is going to go with my x coordinate for my center. So I'm going to do 2 plus 9 and 2 minus 9. So if I do plus 9 right here, 2 plus 9 is going to get me 11, negative 4. So that's going to be kind of off my graph a little bit right there because my graph only goes to 10. And then if I come over here and do minus 9, 2 minus 9 is negative 7, negative 4. So that's going to be 2, 3, 4, 5, 6, -7 right there. So those are my vertices. I'm going to label them with a V, just to kind of help us a little bit. Now, my co-vertices come from my other number. My co-vertices come from the other denominator, which my co-vertices are dealing with that 9. Remember, we got to take the square root of it, though, so that's going to give me 3. And that, since my vertices went with my x, my co-vertices are going to go with my y. And for these, I'm going to do kind of the same idea, but instead of adding or subtracting it from the x, I'm going to add or subtract it from the y. So I'm still going to have the 2, and let's say we do -4 minus 3. That would get me to the -7. So 2, -7. And let's say we're going to add it. -4 plus 3 would be -1. So right there. And I'm going to do CV for my co-vertices. And those points are going to be the guide for my ellipse. So it's going to go through the vertices and the co-vertices, and that's going to be my oval, my ellipse. I suck at drawing, so please don't judge my drawing, but there's my ellipse. Then the last thing we need is that foci part. And remember, that's this equation I have highlighted in purple up here. The c squared equals a squared minus b squared. You may notice it's really, really similar to the Pythagorean theorem. It's just subtracting instead of adding. So a squared minus b squared. So I'm gonna do it kind of over here. Let's do a squared minus b squared equals c squared. And the nice thing is you already have them squared here in your equation. So a squared is 81, b squared is 9. If I do 81 minus 9, that gets me 72. But that is c squared, so I do have to square root both sides. So c is equal to the square root of 72. I need to simplify that and break that down. I do know that's 2 times 36, and 36 is a perfect square, square root being 6, so that breaks down to 6 square root of 2. So we know that it's going horizontally, it's parallel to the x-axis, so for my foci, I'm going to add or subtract that 6 square root of 2 to my x. So you can write that as 2 plus 6 square root of 2, -4, and 2 minus 6 square root of 2, -4. Okay, I don't know about you. I don't know exactly what 6 square root of 2 is. I do know that 72 is in between some perfect squares, right? So if we're looking at our perfect squares, it's less than 81, so it's less than our 9 squared, right? But it's greater than 64, or 8 squared. So it's going to be somewhere in between 8 and 9. It is kind of closer to the 81, probably a little bit closer to that. So it's going to be kind of in between 8 and 9. So 2 plus 8 to minus 9-ish is going to be real close to our vertices. You also can just use your calculator and do 2 plus 6 squared root of 2 and get a decimal approximation if you would like to do that as well. And that's our foci. The last thing it's asking for is the major axis length and the minor axis length. So if I'm looking at this, the major axis is the bigger one, the longer one. And it's asking for the whole length of that. So you can just count, or we can kind of look and cheat code it a little bit and know that our vertices are on our major axis, and we added 9 and subtracted 9 from our center. So I know that I went 9 this way and 9 this way. So I could do 9 plus 9 and get 18, or 2 times that 9. The minor axis, same thing, but it's the shorter one. We can cheat code it a little bit. We know we've got 3, so we went up 3 and down 3. So I know that I'm going to have 3 plus 3, or 2 times 3, which is 6. There's our ellipse and some of the key features for our ellipse. let's do another one just to kind of make sure we know what's going on here. So for example, 2, same idea, but you'll notice this time the bigger number is under the y. So this time it's going to be parallel to the y axis and it's going to open up and down. Okay, my center, x plus 5 means I'm going to have a negative 5. Y minus 2 means I'm going to pull positive 2. So it's negative 5, 2. So let's put that on our graph right there. Negative 5, 2 for my center. If I'm looking at 16, the square root of that is 4. So for my vertices, I'm going to add or subtract 4 to the y value because it's parallel to the y-axis this time. It's going up and down. So if I add 4 to 2, that's negative 5, 6. If I subtract 4 from 2, that's negative 5, negative 2. So right here and right here. Another thing you can do if you want to is you could actually put the points on the graph first. If I know that it's going to be 4, I can count up 1, 2, 3, 4 and count down 1, 2, 3, 4 and then get the points if that's something that's a little bit easier for you. Okay, my covertices come from my other number, my b, so I got to take the square root of that, which is 4. The square root of 4 is 2, so I'm going to add 2 and subtract 2 from my x value. Or you could count over to the right 2 and to the left 2. So the points that would go with that it would be negative 7, 2, and negative 3, 2. And we've got enough points to go ahead and draw our ellipse. Try and draw it a little bit better. Like I said, I'm not very good at drawing. Okay, we need to find our foci. So remember that's the a squared minus b squared equals c squared. A squared is 16. B squared is 4. So 16 minus 4 is 12. We got to square root that to figure out what c is. So c is equal to the square root of 12. I can't leave it like that though. I do know that's 3 times 4, and 4 is a nice perfect square. So that's going to be 2 square root of 3. So remember, we are parallel to the y-axis, so I'm going to add or subtract 2 square root of 3 to my y values. So you got to make sure you're keeping straight if it's parallel to the x-axis or the y-axis. So if I'm looking at that, it would be negative 5 to plus 2 square root of 3, and negative 5 to minus 2 square root of 3. Okay, if we're looking for decimal approximations of that, 2 plus 2 square root of 3 is about 5.4. 1, 2, 3, 4, 5 is about right there. And 2 minus 2 square root of 3 is about negative 1.46, about right there. Then the length of my major axis, that's going to come from that 4. So I'm going to do 2 times 4, which is going to give me 8. The length of my minor axis is going to come from that 2. 2 times 2 gives me 4, which it would be 1, 2, 3, 4, all the way across, right? And same thing here. 1, 2, 3, 4, 5, 6, 7, 8, all the way up and down. So kind of checks out there. Right. Now let's look at some questions that are kind of dealing with ellipses. We have some key characteristics and we need to figure out what the equation is. So it says write the equation of an ellipse with a major axis of 8 and foci at 0, 2, and 0, negative 2. So the first thing I'm going to do is I'm going to kind of build the base of my equation. So I know I have a fraction plus a fraction equals 1. It always equals 1. Then I'm going to have x and y and the squareds. So I'm going to use my other information to kind of help me figure out what's going on here. And I'm going to do a graph because I'm a visual person. So I'm going to draw a graph to kind of help me out. So it tells me that I have a major axis of 8, and then I have foci at 0, 2, and 0, -2. So I'm going to start with the foci. I'm at 0, 2, that's right there, and 0, -2, that's right there. And that kind of gives away where the center is. The center's got to be exactly in between them. So my center is at 0, 0. So technically that's -0 and -0, which I don't really need to write it that way. So I'm going to erase this. And instead of x minus 0 and y minus 0, you can just write it as x and y squared. You don't need the -0 part. This also tells us that we are parallel with the y-axis because the foci are on the major axis. They're always in line with the vertices, right? So I know I'm going up and down. So then my major axis being a length of 8, if I split that in half, I know I'm going to go up 4 and down 4. So 1, 2, 3, 4, there's going to be a vertice. 1, 2, 3, 4, there's going to be another vertice. That also gives me my A value of 4. And since we're going with the y-axis, I know it needs to go under my y over here. And so A squared would be 4 squared, which is 16, and that's going to go right there. So the last thing I need to figure out are those co-vertices. And that's where that kind of weird Pythagorean theorem is going to help me a little bit. My weird Pythagorean theorem, remember, is a squared minus b squared equals c squared. Well, I just said that a squared was 16. We're trying to figure out what b squared is, but I know my foci right here are 2 away from the center, which means that c is 2, and c squared would be 4. And I can work backwards to figure out what b squared is. So I'm going to subtract 16 from both sides. So negative b squared is going to be negative 12. Divide both sides by negative 1. So b squared is 12. And square root it. So b is the square root of 12. We need to break that down, but luckily we already did it up here. The square root of 12 breaks down as 2 square root of 3. But same thing, that really doesn't matter because remember right here, we just need what b squared is, which is that 12. So be careful that you are squaring whatever number goes right there. And there's my equation. And then example 4 is write the equation of the ellipse graphed below. So same thing, I'm going to start with fraction plus a fraction equals 1. In my opinion, this one's a lot easier than example 3 where it just tells you little bits and pieces. I know where my center is. It's drawn for us very nicely right here at negative 3, negative 1. So that means I have x plus 3 squared and y plus 1 squared. If you look, we're going up 1, 2, 3 here, and we're going over 2 here. So once again, we're parallel with the y-axis. So that means that a is that 3. So a squared would be 9, and it's going to go under the y. And the b is how far over we went, the 2. So b squared would be 4, and it's going to go under the x. That one is a lot easier because you don't have to do all the extra work with the weird Pythagorean theorem. And there's my equation. So that's ellipses. The next thing we're going to look at is hyperbolas, which are ellipses but with subtraction. So instead of going towards each other to make an oval, they kind of open away from each other. So, like I said, they now have subtraction signs instead. And so it does matter if you have an X or a Y first, and that's what tells you which way it opens. If the X comes first, then it's opening sideways. If the Y comes first, it's opening up and down. Okay, if you're looking at this, the center is still the HK, the foci and the vertices, still you find them the same way. What's different this time is you have asymptotes. And so those kind of come from the foci and the foci vertices and co-vertices and all of that. And also what's different is now our equation with all of our vertices, co-vertices, and foci is actually the Pythagorean theorem instead of the weird Pythagorean theorem with the subtraction. So the other thing that's new is this one has asymptotes. So part of your asymptotes is your H and your K that come from your center and from your equation. And then the other part is your B that comes from the minor axis and your A that comes from the major axis. And that B over A plus or minus B over A makes like the slope of those asymptotes that are these kind of diagonal lines that kind of help guide your hyperbola. So let's look at some examples. Let's see how we can get these graphs. 5 says graph the hyperbola and identify the key features. So the first thing I'm going to notice is that y comes first, so it's going to go up and down on the y-axis. Okay, you also do have to be careful here because the y comes first, the h is with the x, and the k is with the y. So when I do my center, x plus 1 means that I'm going to take -1 for the x value of my center, and it's technically in the second fraction, so be careful with that. And then y minus 2 means that the y value of the center is that 2. So -1, 2, there's my center. Okay, in this one, it doesn't matter which number is bigger, it matters which one comes first for you finding your vertices. So the 4 is first, that's what's going to give us our vertices. I'm going to do the same square root of 4 to get me 2, so this 2 is going to be added to the y value and subtracted from the y value of my center. So that means I'm going to go up 2 and down 2 to get my vertices. So -1, 4, -1, 4, and -1, 0. So this one, the vertices come from the first number every single time, whereas for ellipses, it comes from the bigger number. So make sure you're paying attention to that. My co-vertices then are going to come from the second number, that 25. If I take the square root of that, that's 5. So the 5 is going to be added or subtracted from my x value. So I could go over to the right 5 and left 5. So -1 minus 5 is -6, 2. -1 plus 5 is 4, 2. That's going to give me my co-vertices. Okay, now finding the foci is just the quadratic formula. Or not, sorry, the Pythagorean theorem, not the quadratic formula. What am I talking about? Pythagorean theorem. Okay, a squared plus b squared equals c squared. So a squared is that 4, b squared is the 25, and then I need to find c squared. So 29 is equal to c squared. Square root both sides, so c is the square root of 29. And that one cannot be broken down, so we're just going to leave it like that. The square root of 29 is going to be added and subtracted from the y value because we're parallel with the y-axis. So -1 to minus the square root of 29, and -1 to plus the square root of 29. If I'm looking at this, 2 minus the square root of 29 is about -3.38, about right there. And then 2 plus the square root of 29 is 7.38. 1, 2, 3, 4, 5, 6, 7. Oh, right there. And those are my, okay. Okay, now here is my Miss Dodgen shortcut for finding your asymptotes. You may have noticed that there's these little boxes on our drawings. So we're going to do the same thing. We're going to draw a box. The box is going to connect your vertices and your co-vertices. So I'm going to draw my vertices going out to my co-vertices. And then I get this little rectangle. My asymptotes are going to make the diagonals of the rectangle. And that's also going to help you figure out your slope. You don't have to necessarily remember that it's the b over a. If I go from my center to the corner here, that's up 2 and over 1, 2, 3, 4, 5. So plus or minus 2/5, because then my other diagonal is going to go down instead of up. So it's going to go down to and over to this corner. So there's the little shortcut for these asymptotes. So remember, it's y minus k is equal to plus or minus your slope times x minus h. And you already know your h and your k from your center. So y minus 2 is equal to plus or minus 2/5 x, and then I'm going to do plus 1 because minus and negative becomes plus. Then the last thing to do is actually draw the hyperbolas. So I'm going to go from my vertices out to those asymptotes. So this one makes a real wide hyperbola. And there we go. Right, let's do another one. And you'll notice this one looks a little funny. Okay, notice that all of our equations equal 1. So we need to make this equation also equal 1. So to do that, I need to divide by 144, because 144 divided by 144 is 1. Then you'll also end up simplifying those fractions. 9 over 144 is going to give me 1 over 16, or x squared over 16. Then the 16 over 144 that's with the y squared simplifies. 16 over 144 is 1 over 9. So we get the y squared over 9. And then 144 over 144 equals 1. So now this is the equation that I'm going to use. So you got to make sure it equals 1 when you're looking at these. Okay, if you look, our x comes first, which means we are going to be parallel with the x-axis. And so we're going to open sideways. My center, if you notice, there's nothing being added or subtracted from the x and the y, so that means my center is 0, 0 at the origin. Nice and pretty. My vertices are going to come from that 16. So the square root of 16 is 4. So that 4 is going to be added or subtracted from the x value, which when it's 0, that makes it really easy. -4, 0, and +4, 0. My co-vertices are going to come from the 9. The square root of 9 is 3. So the 9 is going to be added or subtracted from the y. So 0, -3, and 0, +3. And the foci is the Pythagorean theorem. So a squared plus b squared equals c squared. So 16 plus 9 equals c squared. 16 plus 9 is 25. And so this time, when we actually do take the square root, c is a nice pretty whole number, 5. So we are parallel with the x-axis, so that 5 is going to be added or subtracted from my x. So -5, 0, and 5, 0. We're going to draw our boxes connecting our co-vertices and our vertices in the pink and the blue. And then that's going to help us find our slope. We go up or down 3, and then left or right 4. So it's 3/4. It would help if I could draw these a little bit better. So here's my diagonals. And remember, it's y minus k plus is equal to plus or minus the slope times x minus h, which makes this one really nice and easy. H and k are 0. It's just y equals plus or minus 3/4 x. So I just need to draw my actual hyperbola. There it is. Okay, we got 2 more examples, kind of like we did with the ellipse. We're going to take some key characteristics and write our equations based off of that, and then we're done. So, example 7, write the equation of a hyperbola with vertices 3, 0, -3, 0, and foci -4, 0, and 4, 0. So, let's start with our base. We're going to have a fraction minus a fraction equals 1. But this one I can't determine if it's x or y first until I start looking at my picture. So I'm going to draw a picture over here, and it tells me that I have vertices at 3, 0, and -3, 0. So 3 zeros over here and -3 zeros over here. If my vertices are on the x-axis, that means we're parallel to the x-axis. So we're opening sideways, so x is going to come first. And based off of where our vertices are, that also tells me that my center is right there at 0, 0. So it's going to be x squared and y squared, no plus or minus anything. Okay, I also know my vertices are 3 away. So underneath here is going to be a squared, and a is 3. So 3 squared is going to be 9. So underneath my x squared is 9. So that gives me almost all my equation just from the vertices. Now let's look at the foci. It tells me they are at -4 and 4. So they're just one more out. Means that my C is 4, my A was 3, and I can use my Pythagorean theorem to figure out what my B was. So A squared plus B squared equals C squared. A squared I already know is 9, plus b squared is going to equal 4 squared. So 9 plus b squared equals 16. Subtract 9 from both sides, so b squared is going to equal 7. And remember, underneath our y squared is b squared. So I don't even need to figure out what that square root is. I'm just going to put the 7 and call it a day. Don't do the extra work like we did last time. Save ourselves some time. And there's my equation. that's it. We're done with that one. Okay, and then example 8, like I said, I think it's a lot easier to get the equations from graphs because all the features that you need are already there for you. So fraction minus a fraction equals 1. Hyperbolas are fraction minus fraction. Ellipse is fraction plus fraction. And I already can tell that it's opening sideways, so it's going with the x-axis because it's opening x way. So I know that I'm going to have an x and then a y. My center over here is at 3, 5. It's going to be x minus 3 and y minus 5. Then I can count from that center to my vertice right here is 2. So I'm going to do 2 squared to go under my x, which is 4. And then I can count to my co-vertice, 1, 2, 3, 4. So 4 squared gives me the 16 that's going to go under my y part. And there is my hyperbola. And that's it for this notes. I know it was kind of a longer one, trying to fit ellipses and hyperbolas into one day. They were supposed to be separate, but we lost a lot of days this year, so they're together. So that's it for the set of notes. Make sure you get started on your assignment that goes with this. If you have any questions, let me know. And you guys have a good day.